Hello, this is Dr. Hanaa Assil, and this is paper 2-1 in November 2021 in the IGCSE Chemistry, Cambridge. So let's take a look at the questions and discuss the answers. The first one says decane has a freezing point of -30 and a boiling point of 174. Now, a small sample of decane is placed in an open beaker in an oven at a temperature of 120. What happens to the decane? Now, temperature of 120 means we have passed the freezing point, so it's a liquid. But we have not reached the boiling point, so we can't say that it boils. But what does it do? Remember that any liquid at any temperature would evaporate. So you're heating it 120. It hasn't reached the boiling point yet, but it is evaporating. A student put exactly 25 centimeter cubed of dilute hydrochloric acid into a conical flask. The student added 2.5 grams of solid sodium carbonate, measured the change in temperature. Which apparatus does the student need? Well, let's take a look. He needs 25.0 centimeter cubed. What do we use to measure that? A pipette. Now he needs 2.5 grams of the solid. We need a balance. And he needs to measure the change in temperature, so we need a thermometer. So that is C. Then a student separates sugar from pieces of broken glass by dissolving the sugar in water and filtering off the broken glass. Of course, when he does the filtration, the broken glass will be collected in the filter paper as residue. So what would be the filtrate? The filtrate will be the sugar dissolved in water. Which statement explains why metals conduct electricity when solid? You should remember that metals are made up of regular rows of positive ions surrounded by delocalized electrons. So the atoms are not free to move. It is the electrons which are free to move. Which description of brass is correct? Remember, brass is an alloy. We said it is an alloy of copper and zinc. And remember that alloy is mixture of metals. The equation for the reaction of iron 3 oxide with carbon monoxide is shown. What is the maximum mass of iron that can be made from 480 grams of iron 3 oxide? So he's starting with 480 grams of iron 3 oxide. So I can get the number of moles, mass over molecular mass. Now, if you calculate the MR of Fe2O3, it is 160. So that means I have 3 moles. We look at the equation and we see that from the equation 1 mole of Fe2O3 will give 2 moles of Fe, and that means that the number of moles of iron is twice that of Fe2O3, and from this number of moles I can get the mass of iron, number of moles times Mr, so that comes out to be 336 grams. Which statement describes the attractive forces between molecules? Now, you need to remember when we're talking about molecules, he's probably talking about simple molecular structures. Simple molecular structures, they have strong covalent bonds within them. So, for example, carbon dioxide, it has strong covalent bonds inside. But if we're talking about the attractive forces between the molecules, they will have weak attraction forces between the molecules. So they don't have strong covalent bonds. They don't have they have strong covalent bonds that are inside, but they don't hold the molecules together. They don't have strong ionic bonds. They are weak forces between the covalently bonded molecules. So the attractive forces between molecules are weak forces between the molecules that have in them covalent bonds. Which statement about carbon is correct? Okay, let's take a look. He's saying diamond and graphite both have simple molecular structures. Is that correct? Diamond and graphite, you should know, have giant macromolecular structures. Now, he's saying diamond and graphite are both used to make cutting tools? No, only diamond. Each carbon atom in diamond is bonded to 3 other carbons? No, in diamond, each carbon is bonded to 4 other carbons. It is the graphite that has the carbon bonded to 3. Now, he says graphite conducts electricity and has a giant covalent structure. Well, yes, that's correct. It conducts electricity because we said it has free moving electrons, and it does have a giant structure that has covalent bonds between the carbon atoms. The formula of an aluminium ion is Al3 plus. What is the formula of aluminium sulfate? Okay, in order to write the formula of something, we put the valency of one under the other. So if we say I have aluminium 3 plus, that means its valency is 3. That means I write the 3 under what? Under the sulfate. Now, what is the valency of sulfate? You should know that sulfate is 2, so it has to be Al2, and it is the SO4 that has 3 under it. Which statement about the products of electrolysis using inert electrodes are correct? Well, let us see. The first one says when molten lead bromide is electrolyzed, bromine is formed at the cathode. Well, okay, let's think about it. Lead bromide molten means I have lead ions, lead 2 plus and Br minus. Now, he's saying the bromine is formed at the cathode. Which one is the cathode again? The cathode is the negative, and the bromide is negative, so it will not go to the negative. It will go to the anode. So actually the bromine is formed at the anode, not at the cathode. Okay, then he's saying when dilute sulfuric acid is electrolyzed, oxygen is formed. Well, let us think about it. Dilute sulfuric acid means I have the ions from the sulfuric acid, and I have the H plus and the OH minus from the water. Now, that means that if we're talking about the anode, which is positive, I'm looking at the negative ions. Which of these negative ions will work? We said the sulfate never works. It is the OH minus that will react. Now, when the OH minus reacts at the anode, it gives what? You should remember that it gives oxygen gas. Okay. When concentrated aqueous sodium chloride is electrolyzed, sodium is formed at the cathode. Well, let's look at this. Concentrated aqueous sodium chloride means I have Na plus and Cl minus and H plus and OH minus from the water. Now, which one will be formed at the cathode? So which one will go to the negative and react? Remember, if we have a choice between Na plus and H plus, it is the H plus that will react, not the sodium. So I will have hydrogen, not sodium. When concentrated HCl is electrolyzed, if chlorine is formed at the anode, well, let's see. Concentrated HCl means I have H plus and Cl minus and H plus and OH minus from the water. Now, which one will react at the positive? Remember we said if we have a choice between chloride and OH minus, it is the one present in higher amounts. So if he says concentrated, that means I have more chloride, so that will form chlorine. So I want 2 and 4, so my answer is C. Can you see how we think about these questions? Please take them one by one, decide which is right and which is wrong. Chlorine reacts with ethane to produce chloroethane and hydrogen chloride. The reaction is exothermic. He gives me the bond energies in the table and he's saying what is the energy change. So I'm trying to calculate delta H from bond energy. So what do we have? We have 6 CH bonds. So that is 6 times 410 plus 1 CC bond. So that is 350 plus 1 Cl bond. That is 240. So these I need 3050 kilojoules to break all the bonds in the reactants. Now let us take a look at the bonds in the products. The bonds in the products will form 5 CH bonds plus, so that's 5 times 410, plus I have 1 CC bond, so that's 350, plus I have 1 CCl bond, so that's 340, and 1 HCl bond, that's 430. So the bonds in the products will release 3170. And we said in order to get delta H, it is the reactants minus the products, because the reactants, you need to give it energy, the products will release energy, and that means that my delta H is minus 120. Hydrogen is used as a fuel in rockets and is also used in hydrogen fuel cells. Now, which statements are correct? Both uses produce water vapor. Well, yes, when you burn hydrogen, it produces water vapor, and in the fuel cell also you're reacting hydrogen with oxygen. Now, burning hydrogen produces polluting gases? Actually, no, because when you burn hydrogen, all it gives is water. A fuel cell produces electricity? Yes, of course, so I want 1 and 3. Which statements about the effect of increasing the temperature on the rate of a reaction are correct? So if I increase the temperature, it increases the rate? Yes. It increases the activation energy. Remember, the only thing that will affect the activation energy is a catalyst. We said the catalyst lowers the activation energy. What the temperature does is that it gives the particles more energy, so more particles will have energy higher than activation energy. But I did not change the activation energy itself. It increases frequency of collisions, yes, because particles will move faster, so there will be more frequent collisions, so it is 1 and 3. Ammonia is made by reacting nitrogen and hydrogen. I'm going to remind you again that this is called the Haber process. The forward reaction is exothermic, which changes in temperature and pressure would decrease the yield of ammonia. So I want this reaction, and I want something that will favor the backward reaction, or we cause the point of equilibrium to shift to the left. Then I get less yield of ammonia. So if this forward reaction is exothermic, I want it to go backward, which is endo. Now, if I want it to go endo, should I increase or decrease the temperature? You should realize that if I want it to go endo, I raise the temperature. So my answer is C or D. Then pressure, I'm trying to make it to go to the side that has what? More molecules. That means I need to decrease the pressure, allow it to form more molecules. X is a pink solid, Y is a blue solid. So what is he talking about? Is he talking about cobalt chloride or copper sulfate? Remember that copper sulfate is something that turns from white to blue. But pink and blue, then we're talking about cobalt chloride. And he's saying when X is heated, water is produced and the solid turns blue. When water is added, the solid turns pink. So which one is X? Which one is the pink? You should remember that the pink cobalt chloride is the one that has water. So it is the hydrated, because when we do test for water, we say what? Add water to anhydrous cobalt chloride, it turns from blue to pink. So the anhydrous is blue, the hydrated is pink. So my answer is B. Iron 2 chloride solution reacts with chlorine gas. The equation is shown. Which statements about this reaction are correct? Well, let us take a look at this reaction. Well, he's saying Fe2 plus is reduced to Fe3 plus. No, you should know that when Fe2 plus changes into Fe3 plus, that means it is losing electrons, and that means it's oxidation, not reduction. Now he's saying the chlorine acts as a reducing agent. No, because the chlorine, what happens is it will gain electrons. So that is reduction. And we said that the one that is reduced is the oxidizing agent, not the reducing. Fe2 plus each will lose an electron. Yes, we said it will lose an electron or to form Fe3 plus. The Cl2 are reduced to Cl minus. That is correct. When it gains electrons, that is reduction. So I'm looking for 3 and 4. Which row describes the properties of an acid? You should remember, what was the definition of acid? Proton acceptor or proton donor? Well, you should know that an acid is a proton donor. pH more than 7 or less than 7? You should know that acids have pH less than 7. Which element forms an amphoteric oxide? I'm going to remind you again. Oxides of metals sometimes are basic, or in most cases are basic. So calcium oxide, copper oxide, and so on are basic. That means they react only with acids. But some are amphoteric. So you should remember that oxides of zinc and aluminium and lead are amphoteric, and that means they react with both acids and bases. Cobalt 2 chloride crystals are made by adding solid copper 2 carbonate to dilute hydrochloric acid until no more dissolves. Which process is used to obtain pure crystals from this mixture? So he's trying to make copper chloride. He's adding what? He's going to add excess solid copper carbonate. That means the first thing he needs to do is filtration. And then in this case, the residue is something I don't want. It's the excess copper carbonate. So I'm going to take the filtrate and do what? Crystallization or evaporation in order to get crystals. Moving from right to left across the periodic table, the elements show increasing metallic character. That is right. Remember, he's moving from right to left. That means, for example, from group 7 to group 1. So the metallic character increases. That's correct. Now, why does the metallic character increase from right to left? We know that for a metal to be more reactive, it should be able to lose electrons more easily. So why is group 1 more metallic, for example? This is because they lose electrons easily to form positive ions. A period of the periodic table is shown. The letters are not their chemical symbols. Which statement is correct? Well, you should see that we have group 1, 2, 3. These are metals. The others are non-metals. Group 8, of course, is something that does not react. So which of these is correct? Element R does not conduct electricity? Well, I will disagree because element R is in group 1 and that's a metal. So it would conduct electricity. Elements R and Y react together to form an ionic compound? Yes, I would agree because R is in group 1 and Y is in group 7, so something like sodium and chlorine would react. Now, element Z exists as diatomic or reacts with element T. You should remember that Z is in group 8, anything in group 8. First of all, exists as monatomic gases that do not react with anything. Okay? Group 7 elements show trends in their physical properties going down the group. Which row shows the missing headings for the properties in the table? Okay, so we have something going down group 7. It is increasing from minus 100 to 114. The other one is increasing from minus 3 to 184. So I would say that, of course, X is lower than Y. So X has to be the melting point and Y the boiling point, and then Z could be the density. So my answer is B. Some properties of two metals are shown. So these are two metals. Which row about metals G and H is correct? Okay, he's saying metal G will form GCl and reacts with cold water. So obviously it is in group 1. It's not in group 2 because if it's in group 2, it will form GCl2. Its valency will be 2. So the valency is 1, so it has to be in group 1. So A or B. Now, metal H, he says, has high melting point, has more than one oxidation state. So, of course, that is a transition metal. Noble gases are in group 8 of the periodic table. Which statement explains why noble gases are unreactive? You should remember that noble gases are unreactive because, first of all, they have full outer shells, but I cannot say they all have 8. Remember, it's not all of them have 8. We have helium that has only 2, but they all have full outer shell. Okay? Of course, they are gases and monatomic, but that's not why they are unreactive. Are we following that? Which statement is correct for all metals? Okay, so when he says all metals, you have to remember what are the physical properties of all metals. All metals conduct electricity. All metals are malleable and ductile. All metals are shiny. But I cannot say anything about density or melting point. They definitely don't gain electrons, they lose electrons, so they conduct electricity when molten. Which statement about the extraction of metals is correct? So he's saying aluminium is extracted from bauxite. Well, actually, that is correct. We know that in the extraction of aluminium, my ore is bauxite, not hematite. So remember that bauxite is the ore for aluminium, hematite is the ore for iron. Okay. Aluminium objects do not need protection from corrosion. Remember that we said aluminium is supposed to be a reactive metal, but it is actually, does not react. So iron object must be protected from corrosion. Which statement explains why aluminium resists corrosion? Why is it that aluminium, which is supposed to be reactive, but actually it does not react? We said this is because aluminium has a protective oxide layer. Okay, which statements about the thermal decomposition of copper nitrate are correct? First of all, what is meant by thermal decomposition? It is the breakdown of a compound using heat. Now, if I do thermal decomposition of copper nitrate, remember that nitrates of metals that are not in group 1, if I heat them, they give what? They give the oxide. In this case, it will give copper oxide. It gives a reddish brown gas because it gives nitrogen dioxide gas, which is reddish brown, and it gives the gas, which is oxygen, that relights a glowing splint. So when I heat copper nitrate, I get a brown gas is formed, that is nitrogen dioxide gas. A gas which relights a glowing splint, that is oxygen gas. Now, the solid residue is acidic oxide? No, it's basic. It's oxide of a metal. So it's basic. So it's 1 and 2. Okay? Covering iron with zinc prevents the iron from rusting even when the zinc is scratched. Covering iron with tin prevents the iron from rusting, but when the tin is scratched, the iron underneath starts to rust. Remember, when I protect iron, I can either cover it with a more reactive metal. So in this case, zinc is more reactive, and we said that means this is because the zinc will lose electrons and become oxidized instead of the iron. Or I can protect it with a less reactive metal because when it is covered with something like tin, the tin will not react. So which of these statements is correct? Both tin and zinc prevent iron from rusting by sacrificial protection? No, sacrificial protection means I put a more reactive metal, not something less reactive like tin. Both tin and zinc prevent iron from rusting by stopping water and carbon dioxide reaching from the iron? No. Remember, we said zinc protects the iron not by stopping water and, of course, not carbon dioxide at all. We don't need carbon dioxide, it's oxygen. But we said zinc reacts instead of the iron. Tin is more reactive than iron? No, tin is less reactive than iron. Zinc loses electrons more easily than iron, so it prevents iron from rusting by corroding first? Yes, that is how galvanizing works. Which statements about the Haber process are correct? Again, which one was the Haber process? Nitrogen plus hydrogen to give ammonia. Okay, I'm going to remind you that in this case, the conditions are the pressure is 200 atm, the temperature is 450, and the catalyst is finely divided iron. And we said, where do we get nitrogen and hydrogen from? You should remember that we get nitrogen by fractional distillation of liquid air. So that first statement is correct. We get hydrogen by reaction of steam with methane, or we said the raw material is hydrocarbons or crude oil. Now, the catalyst for the Haber process is what? It's not vanadium oxide. Remember, vanadium oxide is the catalyst for contact process. For the Haber that we're talking about, the catalyst should be finely divided iron. So only 1 and 2 are correct. So my answer is B. Which raw material is used in the contact process? Again, what is the contact process? Burning sulfur dioxide in air to give sulfur trioxide. Conditions: 2 atm pressure, 450 degrees Celsius, and vanadium pentoxide catalyst. So which raw material is used? We're burning sulfur dioxide in what? We're burning sulfur dioxide in oxygen or in air. So the raw material I need here is air. Lime is used to treat wastewater from a factory. Which substance is removed by lime? Remember that lime is calcium oxide. So that means it is a base. So it will react with which of these? It will react with the acid. So it must be removing the acid, not ammonia, which is a base, or sodium chloride, which is a salt, or sodium hydroxide, which is a base. It will react with the acid. An alkane molecule of the molecular formula C8H18 undergoes cracking. The equation for the reaction is shown. He's telling me that substance R has 2 carbon atoms per molecule, decolorizes aqueous bromine. You should know which kind of organic compound decolorizes aqueous bromine. They are alkenes. So he's saying that R is an alkene with 2 carbons, and I have 2 of them. So what do you think is Q? Q will be the remaining of the C8 and the H18. So if I remove 4 carbons, I'm left with 4 carbons. If I remove 8 carbons, I'm left with 10. So my Q is C4H10. What is C4H10? It is butane. Fuel X produces carbon dioxide and water when it is burned in air. So does fuel Y. So I want X and Y to burn producing carbon dioxide and water. So in order to form carbon dioxide and water, both of them have to be organic compounds, not carbon, not hydrogen, because carbon will give only carbon dioxide, hydrogen will give only water. I want both of them, so X could be CH4 and Y C8H18. Which molecule contains only single covalent bonds? Okay, you should know how to draw all of these, and you should know which one contains single covalent bonds. Remember that alkanes are the ones that contain only single covalent bonds. So propane should be my answer. Propanoic acid is something that has double bond O, single bond OH. Propene is something that has a double bond between carbons. Propyl propanoate also has double bond between carbon and oxygen. So the only one that has only single covalent bonds is the alkane, which is propane. Alkanes react with chlorine to form chloroalkanes. Which statement about the reactions of alkanes with chlorine is correct? Remember that when alkanes react with chlorine, this is called substitution reaction. And if he's asking for the condition, it is UV light. And we said when alkanes react with chlorine or bromine, we remove one of the hydrogens and we put one chlorine so that the other product is HCl. So which of these statements is correct? He says alkanes react with chlorine by addition. No, you should know that this is called a substitution reaction. Only alkenes do addition. The gaseous product turns red litmus to blue. Well, which gas are we forming here? We're forming hydrogen chloride. If you test it with damp litmus paper, it should turn it red, not blue. The chlorine atom in chloroethane is covalently bonded. Yes, of course, it is covalently bonded. So that should be my answer. Now, the general formula of the chloroalkane is CnH2nCl. Well, let us see. If N is 1, then this is C1H. It's not H2N. So this is not the correct general form. Okay, so we have 3 hydrogens, so it is not CnH2n. Okay, part of the structure of a very large molecule is shown. Which term describes the small units? Remember, this large molecule is called polymer. The small units from which it is made is called monomer. Propene reacts with steam to form propanol. Which type of reaction takes place? You should remember. When we react alkenes with steam, well, you should remember also what are the conditions. It needs phosphoric acid catalyst and 300 degrees Celsius. And we open up the double bond and we put an H and then OH. Now, what type of reaction do alkenes do? You should know that it is an addition reaction. Which statement about aqueous ethanoic acid is correct? Well, remember that ethanoic acid is a weak acid, it's an organic acid, but it's an acid. So what are the reactions that acids do? You should know. Acids react with metals to form salt plus hydrogen. So when he says it reacts with magnesium to form a salt and hydrogen, that is actually correct. It reacts with sodium hydroxide to form salt and hydrogen. No, an acid reacts with a base like sodium hydroxide to form salt plus water, not hydrogen. It reacts with ammonium salts to produce ammonia. Which substance reacts with ammonium to give ammonia? It's a base. We said to test for ammonium, we add sodium hydroxide, not an acid. So that is wrong. It turns red litmus to blue? No, of course not. It's an acid. It should turn the blue to red. So my answer is the first one, reacts with magnesium to form salt and hydrogen. That is correct. Last question. The diagram shows the partial structure of pterilene. From which pair of compounds is it made? Okay, it's very important to pay attention to the shaded boxes and the white boxes, and which one is shaded and which one is white. You can see that that first part that has a white box has the acids on both ends, while the shaded box has the alcohol part on both ends. So actually your answer is A. And this is the end of the paper. Thank you for listening. I hope that was useful.